reviewing the homework for Practice 1E. Some think about it questions. We can use the number line here to visualize. Where can we find numbers that have an absolute value less than 3? So that would be your numbers that are between -3 and 3. In other words, the distance away from 0 is smaller than 3, so those numbers are going to be close to 0. And then those would be numbers between -3 and 3, just a verbal description. Okay, where can we find the numbers that have absolute values greater than 3? So those would be numbers that are farther than 3 from 0. So those would be the numbers on the left side of the number line. So that would be numbers less than -3 on the left, or they can be numbers greater than 3. Where can we find numbers that have an absolute value less than -3? Well, that's a distance, correct? So distances can never be less than a negative number because a distance is always a positive number or possibly 0. So a distance can never be less than -3. So where can I find those numbers? Nowhere. And lastly, where can we find numbers with an absolute value greater than -3? So a distance is more than -3. A distance is not a negative number, so any distance will have to be greater than a negative number. So that would be everywhere on that number line. All right, let's go ahead and match these inequalities with their solution graphs. The absolute value of x is greater than -3. Actually, that's just the question that we just worked, right? What numbers are a distance greater than -3 away from 0? So that would look like all real numbers, or h. So we're going to match that one with h. Now, numbers in number 6 that have absolute values that are less than -3. So distance less than a negative number. A distance is a positive number or 0, so a distance can never be less than a negative number. So that would be f, the one with no solution, since it can never be true. Let's take a look at 7. The absolute value of x is greater than or equal to 0. So no matter what value of x I use here, its absolute value will always be greater than or equal to 0. So a distance is always greater than or equal to 0. So that's every number. So we're going to match with h again. And number 8, the absolute value of x is less than or equal to 0. Well, an absolute value being a distance cannot be less than 0 because that would mean that the distance is a negative number, but it can be equal to 0. So there's only just one possibility there. 0 is the only number that makes that a true statement. So that's going to give us choice E. And number 9, the absolute value of x is less than or equal to 3. That would be numbers whose distance away from 0 is less than 3. Numbers that are close to 0. So that would be, well, you know what? I said it was A, but that is not true. I just lied to you. It's actually B because we want a distance that's less than or equal to 3. So that would be choice B. All right, let's take a look at number 10. Numbers whose distance away from 0 is greater than or equal to 3. That would be numbers far away from 0. We'll find those numbers on both sides of the number line, far away from 0. So that would be choice D. We're choosing the one with the filled in circles since there's an or equal to on that inequality. All right, so keeping that in mind, we're going to solve and graph each of the following. The absolute value of x plus 1 is smaller than 2. Those are numbers that are close. So the number inside the absolute value is close to 0. So that means it has to be sandwiched in between -2 and 2. That's a three-part inequality, so we can solve by taking and subtracting 1 from each of the three parts of the inequality. That'll give us values that are sandwiched in between -3 and 1. Here's our solution, and there's the graph of the solution. All right, in number 12, we have the absolute value of x and then a +1 outside the absolute value less than 2. We've got to isolate the absolute value first by subtracting 1, and then we can think about numbers that are inside of that absolute value. What's got to be true about those? If their absolute values are less than 1, that means their distance away from 0 is smaller than 1. Numbers that have a small distance away from 0 are sandwiched in between -1 and +1. So there's our solution, and there's the graph of the solution. For number 13, we have the absolute value of x minus 2 is greater than 1. Where do we find numbers that have a distance away from 0 that is bigger than 1? Those numbers are going to be on the two sides of the number line. So x minus 2 can be less than -1, or x minus 2 can be greater than 1. We need to solve each of these inequalities separately, and we'll get x is less than 1 or x is greater than 3 is the solution set, and graphed on a number line, that looks like this, a disjoint set when we say it with or. Make sure that you have your inequalities pointing in the correct direction. Number 12, that -2 is outside the outside the absolute value, so we're going to add 2 to both sides first before we attack that absolute value. The absolute value of x is greater than 3 when we isolate the absolute value. That means numbers are far away from 0. Where do we find numbers that are far away on the 0? We can find them on the left side of the number line, smaller than -3, or on the right side of the number line, greater than 3. There's our solution set, and here is the graph of that solution set. All right, now we're just going to solve, and we don't have to graph our solution set. We've got to start by undoing the -5 first. We're going to add 5 to both sides. And then we have our absolute value isolated. And the absolute value is smaller than 9. So that means a distance away from 0 is smaller than 9. Those would be numbers that are close to 0. We find numbers that are close to 0 on the number line, sandwiched in between -9 and +9. Add 7 to all three parts, and then divide by 2, and there's our solution set. K is somewhere in between -1 and 8. For number 16, we've got to isolate the absolute value first by subtracting 3. Now we want absolute values or distances that are more than 4. Where do we find numbers on the number line whose distance away from 0 is more than 4? We find them on the left side of the number line to the left of -4, or we can find them on the right side of the number line so that those numbers are greater than or equal to 4. Let's solve each inequality separately. I'm going to multiply each term by 3 in order to clear those fractions, and then subtract 3, bring down my ors, and then for the second inequality, again multiply by 3, and then subtract 3. And our solution set is the disjoint set. W is less than or equal to -15, or W is greater than or equal to 9. For number 17, the absolute value of 7u plus 3 plus 8 is greater than or equal to 2. We need to isolate the absolute value first, subtract 8 from both sides. 2 minus 8 is -6. When we are comparing an absolute value, to a negative number, that's a stop and think situation. So we have what is a distance, which is a number that's either positive or zero, and that number that is a positive or zero is greater than or equal to -6. So a positive number is greater than or equal to -6. That's true. 0 is greater than or equal to -6. That's also true. So apparently this statement is always true, which means that this inequality has a solution of all real numbers. All right, let's take a look at 18. Isolate that absolute value first. We're going to subtract 7. Okay, that's comparing to 0. So I'm going to stop and think. And a positive number is less than or equal to 0? Not true. How about 0 is less than or equal to 0? That's true. So the only time when this statement can be true is when the absolute value is equal to 0. When is an absolute value equal to 0? When its contents are equal to 0. So now we just have one equation to solve by adding 2 and dividing by 3. So there is really only one single solution to this inequality, and that is n is equal to 2/3. For number 19, we need to isolate the absolute value first. So the absolute value of x plus 5 divided by 2 is greater than 7 plus 1 is 8. That's an absolute value or a distance that is bigger than 8. Where do we find numbers on the number line whose distance away from 0 is larger than 8? We find them on the outskirts of the number line. So that means we find them on the left side of -8 or on the right side of +8. Now we can solve each individual inequality, so we can go ahead and clear fractions. Multiply by 2 and subtract 5. Bring down those ors in between. By the way, you need the word or for your solution to have its full meaning. So we need to have those connector word, if it's that connector word there, if it is indeed an or statement. Let's multiply by 2 here and subtract 5. There's our solution set, the x's that are less than -21 or greater than 11. For number 20, we need to isolate that absolute value. If you like, you may change this so that it looks like the same thing, but the terms rearranged so that the negative absolute value comes first. So we need to subtract the 5 from both sides. 9 minus 5 is +4. Now we can divide both sides by -2, and that'll give us -2, but it will also change the direction of the inequality. So the absolute value of x is less than -2. That's a stop and think. And we need to consider that an absolute value can give you a positive number. Can a positive number be less than -2? Not true. Can 0 be less than -2? Also not true. So this is never true, which means there is no solution to this inequality. In number 21, we need to isolate the absolute value first. That means that we are going to subtract 2. And now we have the absolute value of y minus 3 is greater than 0. That's comparing to 0. So we're going to stop and think. And we need to consider if a distance or a positive number can be greater than 0. That's true. Positive number will always be greater than 0. But that distance could also be 0. Can 0 be greater than 0? That's not true. So it seems that this inequality is mostly true, except for when the absolute value is equal to 0. So that means that y minus 3 cannot equal 0, and that means that y cannot equal 3. it's more succinct to say in this instance what y cannot be rather than what y can be. If you like, in number 22, we can rearrange the order of the terms. So we have a negative absolute value plus 7 is greater than 2. And then we're going to subtract 7 from both sides. 2 minus 7 is negative 5. Now we're going to divide through by negative 1 to undo that negative sign in front of the absolute value. When we divide through by negative 1, the inequality switches directions. So now I'm thinking about absolute values or distances that are less than 5. Distance away from 0 less than 5 means that numbers are in the middle of the number line close to 0. That'll mean they're sandwiched in between two numbers, negative 5 and positive 5. Subtracting 3 from all three parts of this three-part inequality gives us that x is sandwiched between negative 8 and positive 2. As you write this one, again, think about the direction of that inequality. We need to be pointing in the same direction, so both of your inequalities need to be pointing toward that negative 8, or the smallest of the three numbers. Last one is a multiple choice. This one's kind of fun. Let's take a look at this word right here. It says that x and y are integers. So integers are your whole numbers and their opposites. So not fractional values, in other words. So let's think about what x can be. If 1 is less than, the absolute value of x is less than 6, that means the absolute value of x has to be sandwiched in between 1 and 6. Well, x could be 2, 3, 4, or 5, just not 1 or 6. But x could also be the opposite of those numbers. So those are really all the possibilities for x. Now, we also know that 2 is less than the absolute value of y, which is less than 5. So the absolute value of y is sandwiched between 2 and 5. So y can be 3 or 4, really, not 2 or 5. But y could also be negative 3 or negative 4, because its absolute value would still be between 2 and 5. So those are all of our possibilities for y. We are looking for the least possible value of x plus y. Well, which are the least values of x, negative 5, and the least value of y, negative 4? So the least, or the smallest value of x plus y would be negative 5 plus negative 4, which would be negative 9 is our answer to that one. All right, have a great day.